Hi, it's Mrs. Guest, and here's the video to review tonight. As a reminder, we're focused on random samples. And specifically for tonight, we're going to be looking at some special types of random sampling. So, techniques. Okay, though we've already talked about the fact that simple random samples are very often used, and we've discussed some ways those might be used, there are a number of other methods, and I want you to be familiar with these, and you'll certainly be asked to make decisions about which of these might be most appropriate in different situations. Okay, so here are the examples that we're talking about. Let me see if I can get this to move a little bit. All right, I'm new to this technology, by the way, so if it's a little choppy, please be forgiving. All right, so the different methods that we can consider beyond random sampling. The first of these would be stratified sampling. Now, we talked about an example where this would be appropriate in the class when we were discussing average shoe size and how we might predict that. That's an example where, because women's shoes are sized differently than men's shoes, it might make sense to break up our class into males and females to different strata, and then within the males choose a random sample, within the females choose a random sample. That would be an example of stratified sampling. The strata, or the groups we'd be talking about, would have a specific characteristic, like perhaps age, income, education level, etc. And all members of the stratum would share that specific characteristic. Then we draw random samples from within each stratum. Okay, the next one we'll talk about is systematic sampling. When we're doing systematic sampling, we would number all the members of the population sequentially from 1 to whatever the total number are. And then we'd pick a random starting point, and we'd include every so many members of the population in our sample. Again, this is systematic sampling. So, for example, if you were going to be doing a study to weigh backpacks, maybe you'd number every single person that you're interested in your population. Let's say that population is our class. You'd give every person a number, from maybe the people who have a last name starting with A to the people who have a last name starting with Z. And then you'd pick a random starting point, maybe generate a random number, use a random number table, and you decide that maybe from that starting point you're going to choose every third person. That's a terrible 3, but every third person. Okay, so K would be equal to 3 in that case. Okay, that would be an example of systematic sampling, kind of numbering all the members of the population, whether it's people or objects. You're picking a random starting point, and then you're taking every so many, some number for K, and including those in your sample. Okay, I'm going to try a different technique here to see if I can erase this. Interesting. Don't love it, but, you know, I'll try something else next time. Getting used to the technology. All right, the next type of sampling would be cluster sampling. Okay, in cluster sampling, now you're dividing the entire population into pre-existing segments or clusters. Okay, might be geographic. So you're going to look at everybody in the Northeast, everybody in the Southeast, everybody in the Midwest, everybody, you know, in the West, whatever the case may be, Northwest, Southwest, and so forth. Once you identify the clusters, then you take a random sample of members. Sorry, you'd make sure that you're including every member of each selected cluster in your sample. All right, so let me try to say that more clearly. So we're choosing the clusters. Then we're going to pick a random selection of clusters. Then we include every member in the cluster. All right. So, you know, if you were to think in middle school, right? In middle school, we actually had clusters. So if we were interested in information about the entire population of the middle school, maybe we'd use the actual assigned clusters as our clusters for the cluster sampling. And then we'd make a random selection of the clusters. So maybe we'd say we're going to pick 2 of them, and we'd randomly select 2 of the clusters. All right. Okay, next we're going to talk about multi-stage sampling. This is kind of a combination approach. This is where maybe you need to kind of take a couple of samples to get down to the ones you're going to focus on. So maybe you decide that you're going to break up the U.S. into geographic areas. Then you're going to break those geographic areas down into smaller blocks that maybe you're going to stratify by ethnicity and maybe some other factors. Then you're going to start looking at housing units in particular blocks to consider, and you're going to create a cluster of those and randomly select the ones you're going to survey. You'll start to hear, right? There's different stages to the approach. That's what we would refer to as multi-stage sampling, where you're creating smaller and smaller groups at each stage until your final sample consists of clusters. So it's a little different. This would be something used when you have a super large population that you're trying to work with. Okay, the last one we'll talk about is convenience sampling. Convenience sampling is perhaps most often used when we're talking about doing studies in the school, say by all of you. This is where you're just using data from a population of members that are readily available to you. You can get to them easily. So this would be, for example, if you were to conduct a survey and maybe you were interested in knowing something about the entire school, but you chose to only ask people in our classroom because they're easily available to you. Perhaps I gave you time to work on it in class, and those were the people you could get to most quickly. That would be an example of a convenience sample. When we're sampling, we have what's called a sampling frame. And ideally, the sampling frame would be the entire population. So everybody we'd be interested in, we'd want to be at least up for consideration to be included in our sample. However, that is not always practical. You'll see an example here. If we were interested in using the telephone directory, let's let that go back down, the telephone directory as the sample frame for residential telephone contacts, right? If we wanted to include anybody with a telephone as part of our population and we wanted to use the telephone directory as our sample frame. The issue with that, of course, would be that the telephone directory does not include unlisted numbers. So our sample frame, if we're using the telephone directory, is not an exact reflection of our population. When this happens, we have what's called undercoverage, okay, when our sample frame does not match the entire population. That's pretty common. We just need to be aware when that's happening, recognize it so it doesn't throw off the results of our study. You know, for example, if you're talking about conducting the census, right? If we can't get to the homeless people or people who are fugitives from the law, etc., then we have an undercoverage. We're not able to include every single person in our population as potential sample candidates. Okay, so the notes you can write about that are here: sampling frame, and then undercoverage. Okay, I'll try to move that over a little bit. Sampling frame and undercoverage. And this word here wants me to use a different color for fun, I guess, is actually. Actually. Of course, it doesn't want to write it down. Actually. Fun for everyone. Now, it's important to recognize that even when the sampling frame and the population match, a sample is never going to be a perfect representation of a population. We talked about this in class, that if we took the average GPA of even the most perfectly selected sample, it's probably not going to match exactly with the average GPA we'd get if we took information from every single person in our population. Okay, so a sample statistic is never going to be quite as good as a population parameter, is the long and short of it. And what we call that is a sampling error. We recognize that the extent to which the sample information doesn't match the corresponding population information is a form of error, or what we call a sampling error. Okay, and the last slide for tonight, there actually are two different types of errors we may encounter in doing sampling. The sampling error I just described, which would be that difference between the measurements we'd get from our sample and what we would have gotten if we were able to measure the entire population. That, again, is caused simply by the fact that the sample doesn't perfectly represent the population. But there's also another type of error, and that is a non-sampling error. If I can get the screen to stop moving. A non-sampling error is a little different. That would be a result of having poor sample design, maybe sloppy data collection, not using good measuring instruments, like in the backpack weight survey, choosing to use different instruments and ones that aren't maybe appropriately calibrated. Bias in questionnaires, and we'll talk a little bit more about bias in the next day, etc. Okay, so it's important to recognize that there is a difference between sampling errors, which just recognizes the difference between what we find from our sample and what we would have found if we were actually using the entire population, and non-sampling errors, which is due to some sort of fault either on the part of the design or the part of how the survey is conducted. All right, that's it for tonight. I know that's a lot for the notes, so please feel free to go back, take your time, get what you need, and we'll talk more tomorrow. Take care.